Samvad and welcome to Ek Samvaad at Arunima Ankuran on the occasion of International Day of Mathematics, 14th March. We're in conversation with a budding mathematician, Miss Tanya. She is pursuing MSc program in mathematics at VNIT Nagpur. Welcome to Ek Samvaad, Tanya. It's such a delight to have you here.
Thank you, ma'am.
A word about Arunima Ankuran. This is an initiative for positive social change through self-development. The goal is greater well-being and happiness for all. At Arunima Ankuran, we believe that each person is unique and special in some way, that each person can make a difference, that each person can make an impact, and that's what keeps us going and inspires us. So, International Day of Mathematics, the UNESCO's 40th General Conference proclaimed 14th March of every year International Day of Mathematics in November 2019. In many countries, 14th March is already celebrated as Pi Day because pi, one of the world's most widely known mathematical constants, can be rounded to 3.14. Greater global awareness of mathematical sciences is vital to addressing challenges in areas such as artificial intelligence, climate change, energy and sustainable development, and to improve the quality of life in both the developed and the developing world. For instance, the 13th Sustainable Development Goal concerns climate action. The latest report by the Intergovernmental Panel on Climate Change relies on a combination of climate models and storylines to produce scenarios of plausible alternative futures. It is these mathematical models which enable the exploration of multiple what if scenarios to inform the decision-making process. So, mathematics for action, supporting science-based decision-making. UNESCO is releasing its Mathematics for Action Toolkit on 14th March 2022 to mark International Mathematics Day, written by mathematicians and thought leaders from across the globe. It presents riveting research on the many ways in which mathematics is addressing the world's most pressing challenges. So, Mathematics for Action also deciphers the role of mathematics in achieving sustainable development goals to 2030 that were adopted by the global community in 2015. The only way to learn mathematics is to do mathematics. While most people are in a very uncomfortable relationship with mathematics, we have someone who's actually pursuing her postgraduate course. So, welcome to Ek Samvaad, Tanya. It's a pleasure to have you here.
Thank you so much, ma'am. First of all, thank you for giving me this wonderful opportunity. I am Tanya, and I completed my graduation from Kamla Nehru College, University of Delhi, and now I am pursuing my master's from Vishweshwara National Institute of Technology, which is also known as VNIT Nagpur. So it's always wonderful to talk about maths, and that too at some great platform to share something. It's really fortunate. Thank you so much, ma'am.
Welcome. And I'm sure that, listening into this conversation, a lot of students will get to be more interested in mathematics because they can identify with someone as young as you are and so interested in mathematics. So, really, I'm hoping this is going to be a very interesting conversation with you. Um, so, Tanya,
Yes,
first
ma'am.
things first, why did you choose mathematics of all the options that were available?
So to be honest, when I was in school, I was not that good in maths, like average student. But I was like interested into it, but not good into it. So maybe because there was communication gap between me and teachers teaching or other factors. But then I was interested and I then looked for those people who did math. I mean, those who graduated in mathematics, like they had background of mathematics.
Mm-hmm.
So there I found Subramanian Swami. He graduated in mathematics
Mm-hmm.
and then he pursued a master's in statistics. So he was like inspiration for me that
Mm-hmm.
such a great personality has done something. So uh, he was inspiration. So that's how I decided, okay, let's try something new and adventurous
Mhm.
and open. Then I try to open myself for more opportunities, and that is why I'm doing this now.
Wow. Um, so you said as a student you were not very excited about mathematics initially, and you
Yeah.
got inspired by this person. So
Mm.
once you took it up, did you actually feel that it was a good decision?
Actually, when we have hard times, we always question that, have I made a right decision or that was wrong? So I think that's for all. But in the end, when you get something good out of it, when you learn something,
Mhm.
it's positive and it's motivating. So I think that I made the right choice and I have opened lots of different options for myself.
Okay.
So I think I am happy with the decision.
Right. And I'm so happy to see a student who's, actually happy about a choice they made, because nowadays a lot of kids get very lost and they're not able to figure out what they want to do. So it's good to meet someone who's so focused. When you started studying, what was the initial experience like, and what were some of the things that you had to do to be good at it? What were your studying styles, so to say?
So initially, in graduation, I didn't expect that maths is going to be so much theoretical.
Mm-hmm.
I thought it will be like calculations and different things, but I never, in my weirdest of dream, I never had this math is going to be theoretical. But that's true. Math has a lot of theory, lots of theorem, because everything is proved. I think everything is backed up with some reason. So that's why it is. Uh, it has so much of theory. But then I started working out with it. Then my approach is basically I look at one thing, I try to picturize it in my head, like what's going on. If one sentence is there, then think it. Even sometimes it takes half an hour to think that one sentence. But
Okay.
I think that's when you try to understand that that's the whole purpose. It's not like going through the whole book and you'll say, okay, I'm done with the book. That's not how it goes. Sometimes it takes 1 hour to complete one page, but then it's fine because in the end, you should be able to picturize the concept as in what is happening. If you're getting that, then I think everything's going fine.
So it would be very helpful, Tanya, if you gave us an example of what you're saying, a simple one.
Okay, so like there are lots of theorems, very simple ones also. So one theorem is like pigeonhole theorem, which is like, if there are, so if I'm telling with an example, that if there are 10 holes, then and there are 10 birds and there are 10 holes, I mean nest, maybe you can say there are 10 nests and there are 10 holes. So there is a theorem to prove that two birds, they will have to lie in one nest. So this seems
Hmm.
really obvious.
Hmm.
This is really obvious because there are 10 nests, and there are 11 birds, so
Hmm.
the two of them have to be on one nest. But there is a theorem to prove this.
Hmm.
There's a long proof to prove this concept.
Okay.
So everything is, you cannot write anything. You have to give some reasons.
Okay.
So I think this is the interesting part.
And how does it work? How does the logic proceed?
So basically, there is this mathematical induction principle, which says if which says that if something is true for n equal to one, n equal to
Hmm.
one means one in number.
Hmm.
If we prove for n equal to one, we assume it for n is equal to k. Let's say k means any arbitrary number we are fixing.
Hmm.
If we are assuming that, then we'll prove. Then we have to show that it will be true for k plus one also.
Hmm. Okay.
I mean, so for n equal to 1, we proved it and we
Hmm.
assumed it for n equal to k.
Hmm.
Now we have to prove that this thing is going to be true for n equal to k plus 1 also. So if we are able to prove it for k plus 1, we
Hmm.
are done. That means it will be true for, I mean, you can say that thing is in generally true. So that's how it works.
Hmm. So, Tanya, obviously it's very important that the teacher uh, who's teaching mathematics should be able to get the children excited about it,
Mhm.
right? Have you had any such teachers?
When I was in graduation, one of my teachers, he I can say he is an inspirational personality.
Hmm.
He used to tell us that uh, he most of his problems he don't consider them as problems, because as a mathematician he always looks for solutions to of all of them. So I think that I still remember those lines and those words. So that was really inspiration for me. I
Hmm.
mean, something inspirational for me. Yeah. So
The idea that you need to focus on the solutions, you know.
yeah.
Hmm. So when you do a particular, when you're working on a particular problem, so what is Tanya's approach and what is her state of mind? Like, obviously, you need a lot of focus. So how does Tanya work on it?
So primarily, I focus on what is written and try to get materials so that I have material available with me, and then after collecting all of them, I see which is working and which is not working.
Hmm.
So material in the way also that if I need to prove some theorem, then whatever things are required to prove it, I will
Hmm.
look for uh, different things on that topic. I mean, different concepts on that topic. If it is in book or if it is on internet anywhere,
Hmm.
then I'll try to combine all of them if
Hmm.
they are working like in that way. So lots. So there is no guarantee that I'll end up with a solution.
Hmm. But
But
you're
then
trying.
important thing is that I have tried, and I think that's the most important part. So that's how I work.
Okay. So when you study mathematics for the first few years in school, a lot of people end up wondering, what really is going to be the role of mathematics in life, in the sense that what are the applications because of which we should be interested. So talk to us a little bit about that, Tanya.
Actually, ma'am, I also had this when I was in school, when I was in graduation, and I think it's important also because
Hmm.
when you know why you are doing something, it becomes more precious to us. It becomes more valuable. So uh, I also had this thing, but as far as the applications are concerned, there are lots of branches of mathematics, especially applied branch, which include topics like ordinary differential equations, partial differential equations, discrete mathematics. Like discrete mathematics has a good amount of role in computer science, like the digital circuits, circuit diagrams, and graphs, and so all of that has come from this discrete mathematics only. Then data structures also, it plays a really important role in computer science. So that also comes from discrete mathematics. Then ordinary differential equation is about the rate of change of things. Like if there is a wave, then at what rate the wave is going to change. And also it is used in modeling. Modeling is really important part. So what that's what statisticians do, they predict. So there also this ordinary differential, partial differential equations are used. So what advantage a mathematician or a person who has a background of mathematics versus the one who is not having that much background is that a person with math background will be able to understand it
Hmm.
and able to apply things in much more better way.
Hmm.
I mean, you can have both of them can have solutions, but you will have effective solution if you have really worked hard in the subject. I mean, if you know the background, if you know the basics, then probably you'll end up with a better solution,
Hmm.
probably which is less time consuming than others. So there is this thing in computer science
Hmm.
that finding a program is
Hmm.
not sufficient. You
Okay.
should be able to write such a program which is effective in terms of time also. Like it should not consume a lot of time.
Hmm.
So that way, if you are better in what you do, then you'll end up in doing something good only.
Hmm.
So that's how I think with good amount of technical knowledge, uh, you can do great.
Can you think of any recent applications that interested you as a student of mathematics in the global scenario, maybe?
So in graph theory, we have this concept of there are two nodes. Let's say there are two nodes. So in graph theory, we have graphs. Graph means let's say there are 10 nodes and they're joined by lines
Hmm.
joining them.
Hmm.
So that's how we make a graph. So assume that as far as the application point of view is concerned, so assume that there are two checkposts and there's a road joining them. Then
Hmm.
you need to travel from one checkpost to the other, and there are 10 different roads connecting these two nodes. So which one you are going to choose will depend that which is taking you less time.
Hmm.
You should be able to reach faster there, and then it should also be safe for you to reach. So we put restrictions on those. So I think that's where this graph theory application can be seen.
Okay.
So I think we can apply this here also.
Wow. So you have some slides to share with us, Tanya.
Yes, ma'am, sure.
Can we go ahead and do that?
Yes, ma'am, sure. So mathematics is really vast and big subject, but I've tried to keep things as simple as possible here. So on 14th of March, we'll be celebrating Pi Day. So happy Pi Day. And pi is a mathematical constant,
Hmm.
and first three digits are 3.14. So really interesting point here is that many companies do offer good discount on Pi Day. Like a few years back, Microsoft gave discount of 31.4% on some of their laptops. So I think it's a deal day.
Hmm.
So let's move ahead. I think it's always good to start with some humor.
Hmm.
So it says that why did math book look so sad? Because it has so many problems. That's true. Math books are just filled with so many problems, and we rarely find answers.
Hmm.
Then math is the only place where people buy 64 watermelons and no one wonders why.
Yes,
That's true.
absolutely, absolutely.
Then let's move ahead. So math nerds of the world rejoice. So these are some of the examples of CEOs who once had studied mathematics. They graduated
Hmm.
in maths only. So Steve Ballmer, who was former CEO of Microsoft, he graduated in mathematics. And then Sergey Brin, co-founder of Google and former president of its parent company Alphabet, he also graduated in mathematics and computer science. One more interesting thing is that Google is inspired by mathematical term Gogol, which
Hmm.
means 10 raised to the power of 100.
Wow.
So I think this is interesting.
Yes.
And then there's this Reed Hastings, Netflix co-founder, chairman, and co-CEO. He also graduated in maths. Then Indra Nooyi, she's the former CEO of PepsiCo. She graduated in maths, chemistry, and physics. So, for those who think that maths is restricted to some research only, then that's wrong because you can actually do anything, uh, and actually, you'll be having advantage over others. So, they are the examples. You can be CEO also. Then, areas of mathematics. So, basically mathematics, we can say broadly in categorized in two areas. I mean, it has two areas. One is the pure part, the other one is applied part. So, as I just said, that applied part contains problems that can, I mean, real world problems uh, can be solved with the help of applied mathematics. So, as I just said, that ordinary differential equations, partial differential equations, discrete mathematics, all of them are example. Their applications are there in the world. We can
Mm-hmm.
apply them. We need to make a bridge,
Mm-hmm.
and we need to see what kind of slope is required so that the
Mm-hmm.
passage is fine, so that it's, I mean, cars are able to move swiftly. So all these rate of changes, so this can be studied from, I mean, applications can be found from this applied maths. The other one is really interesting part, which is pure mathematics. Pure mathematics is much more intrinsic. I mean, this is not that simple to grasp because one has to understand and make a lot of pictures in
Okay.
mind in
Mm-hmm.
order to understand pure mathematics, because this is something which we cannot see in real world,
Mm-hmm.
although it has applications, but it's hard to see in real world. So a really interesting part of math is that a non-mathematical person might not be able to imagine how ninth dimension might look, but if you have studied some concepts of mathematics, you can imagine how ninth dimension might look like.
Okay.
So that's how it works. An example of pure mathematics could be like metric spaces. There are some spaces.
Mm-hmm.
Spaces are basically uh, uh, so yeah, spaces are basically, they have their own sets of rules and properties. So there is this set, and if this set satisfies some properties
Mm-hmm.
and some rules, then we can say, okay, this is a metric space. That is how this pure part of mathematics work. There's really interesting fun fact. So what the unfortunate thing with math is that you cannot say 1 plus 1 is equal to 11. It has to be 2.
Mm-hmm.
So the interesting part is that initial proof of 1 plus 1 equal to 2 contain more than 360 pages.
Oh my
I
God.
mean, this
Huh.
is hilarious.
Mm-hmm.
How can it be?
Mm-hmm.
So I think that's really interesting, and this is crazy. How can one write 1 plus 1 is equal to 2? By the way, whosoever thinks that they think that 1 plus 1 is equal to 11, then they can make their own system. One can always make their own number system, but
Mm-hmm.
then that has to be proved and backed with some logic and reason.
Okay.
Because what we study now as 1 plus 1 equal to 2 also has some reason and logic,
Mm-hmm.
so they can also do that. Now, hindrances to students of maths.
Mm-hmm.
So
Yes, very important.
there is so hindrances to students of maths. So there are lots of issues faced by students. First one is the lack of proper communication in teaching. So, I think the major problem is that when the teacher tries to communicate a problem or the concept, it
Mm-hmm.
is not effectively taken by students. The reason could be sometimes the teacher is teaching, let's say, for 10 years, and teacher knows everything. So sometimes it becomes obvious for teacher, but that might not be true for student. So sometimes this creates a communication gap.
Mm-hmm.
And then obviously maths is a mentally demanding subject. You should be really ready to accept things. I mean, it's not a reading stuff that you can sleep and you can be in half sleep and read. You can't do that in maths. You have to be full awake in order to do it. And then obviously it's time consuming.
Mm-hmm.
A lot of time is used in practicing stuff. So one has to be patient
Mm-hmm.
in order to grasp the concept. And then many concepts are interlinked in maths.
Hmm.
So what we studied in nursery in first class, 1 plus 1 equal to 2, we still use those.
Right.
Like assume if I have not studied 1 plus 1 equal to 2,
Hmm.
then obviously I cannot build up onto it, because that's the basic.
Hmm.
So that's how they're interlinked. So if you have not attended few classes, then you will not be able to do uh, what the teacher is teaching in the next few classes, because you have missed those previous classes. So that's also the problem with maths. And then I just like to focus on this last point because I think it is really relevant. And the problem is in our education system is that a lot of focus is given on rote memorization.
Hmm.
So teachers want marks, parents want marks. So obviously students think that marks are that much important. Marks are important. So we tend to focus a lot on marks. But then what happens is when we focus too much on marks, we actually let go of this idea of grabbing the concept, and we are rather focused on getting more marks. So I think this focus should change, and this is a problem. Then I would like to share some study tips that I also follow.
Hmm.
So first is open mindedness is really important.
Hmm.
Open minded in the way that if I am going to class and I am not ready to accept what the teacher is going to say, then probably I'm not, there will be a communication gap then.
Hmm.
Because whatever the teacher is teaching and I'm not ready to accept them, then there will be issue. So open mindedness is really important. And then don't wait for exams to study. Like what happened is that students start studying 10 days before the exam, but in that way you are just focused on marks, not actually grabbing the concept. So that's a loophole, I guess. So do it daily, regularly practice it. uh, let's say just for 10 minutes it's fine, uh, but don't wait for the end time to start doing, because in that way we are not learning it, we are just focusing on getting marks.
Very true.
And then ask lots of questions. If you're really scared to ask questions from teacher, then it's fine, Google will always help you.
Hmm.
Have lots of questions, and one has to be really curious and look for answers by yourself on internet. Then this, yeah, don't restrict yourself to get marks. It's important, but I think concepts are more important. And then have short and long term goals. It's really important because long term goals kind of give us direction as in where we can go, and
True.
short term goals are important because uh, otherwise we'll otherwise we'll we will not focus on what's happening at this moment, rather we'll be just living in future,
Hmm.
which is also not right. So it's important that we should have both short and long term goals. And then how mathematics is useful, then obviously it improves our logic. We get this capability of thinking,
Hmm.
and we get this problem solving skills also. It is improved, and it improves our creativity. How creativity is improved, because when you imagine lots of different things which normally a non-mathematical person might not be able to imagine, so obviously you get more creativity. Now mathematics can save lives. Yes, definitely it can, because it improves our logic. So yeah. So there's this humor that you'll not end up fighting with each other for some lame things in life. And then thank you so much. But before ending, I just want to share one thing. So I want to share one incident. So after completing school, I was asked by somebody, as in why I completed this. I
mm,
mean, why I attended school.
mm,
So back then, I used to find that this is no question because
mm,
everybody do that. So obviously, this is no question.
mm,
But then after some time, I realized that this is a really important and nice question. If you are going somewhere and you have no idea why you are going there, then it makes no sense in life.
true. Mm.
So from there, I decided that whatever I do, I will always question myself, as in why I'm doing this and what will I get from this. So I think this is something that many people do not understand, or maybe they have never think that this is important thing. So yeah, I think this is important part.
So, logically speaking, Tanya, tell us why.
uh, so let's say that instead of choosing in this line, I would have decided to do something else. Let's say um, I might have took up arts and then later on studied English,
Mm,
which is not bad, but maybe I am not made for that. So even if I would have done masters and something like PhD also I would have done,
mm,
but then in the end maybe I will not be satisfied for what I have achieved, even if it is really big for some people, but I will not be satisfied because that is not something which I want to do.
mm,
But then the mistake was also mine because I didn't give this thought that okay, I want to do this or not. So it's important that we give a break and think that is this something that I want to do, or this is not that thing. If it is not, you're not enjoying it, then something which is there in your heart, because heart never lies, I think.
mm,
So you can always find answers there.
mm,
So just look out there. So actually I believe that nothing is guaranteed in life.
mm.
Life is really uncertain, but what we can do is we can at least try. That is the final thing.
Wow. And I really think what you said is very precious, Tanya. For a lot of students who are not able to make up their minds, it would be really nice if you walk us through that process of how you zero in on a particular area of study. What are some of the questions you ask yourself? And what are some of the things that help you to choose the direction? For example, we can talk about your own decision.
So I think for most of other students also, till 12th it's fine. I mean, till 12th life is like really good because you get everything. You have no, you don't have to think, as in you don't have pressure. Like parents are there that they'll support you, but then later on when you grow up, you start thinking, okay, so that was the I mean, uh, this happened with me when I was in graduation. I was doing my master, sorry, this graduation in mathematics. That's when I had lots of question in mind that whether am I doing this right thing or not.
Mhm,
So it's a really long process. I used to question and ask, but there were no answers
mhm,
because nobody could answer me the solutions of those.
mhm,
Uh, but then I started searching on internet
mhm.
that as in this beginning I said that I found Subramanian Swami
Yes.
inspired me. So that's how I started searching those people who uh, at some point uh, I mean did their masters and this graduation in maths and other things also. So it was long process, not easy,
Mhm.
uh, but then it was there in my heart that okay, uh, I will follow it, and whatever will happen,
Hmm,
I will see,
hmm,
because at least I am doing something which is there in my heart.
hmm.
So that's what I mean, that was a hook. So I was just grabbing it. I mean, just had it in my hand. I will not let it go. So whatever will happen, we'll see. So
Wow.
that is how it was. And I think it's not easy for anyone.
Hmm,
I mean, for everyone, it's not easy. So I can just say just that, just grab that hook tightly. Don't let it go.
hmm. And keep
Yeah,
at it,
yeah.
right? So, where is Tanya's journey likely to take her? What are some of the areas where you think there is scope for a mathematician like you?
So I basically am interested in maths and its use in mm, data related things.
Mhm,
So that's how I started learning Python. Python is a programming language
mhm,
which is widely used to deal with data.
mhm,
So it so once I have this background of mathematics, I can, and also knowledge of programming languages, I can put that mathematical data into programming language and could probably simplify it
mhm.
or something like that. So I'm interested in combining maths with the uh, computer science. So to do something that
What are
that,
some
that is something I hope.
what are some of the problems that a mathematician like you would be able to solve through the process you've just described in terms of
I
social
think,
relevance, perhaps, maybe?
yeah. So uh, what I can say is our government make lots of modeling. Our government, I mean, their agencies, they have given this work to agencies. They do lots of modeling to solve, let's say, health problems. So they have so the thing is that there is data, there is a lot of data, but then you need to categorize those data.
Mhm,
Like census also, you
mhm,
have this whole lot of data, but then you categorize it and then you say, okay, this is poverty, this much is poverty, and this much is the health problem.
mhm,
So that's what we do. So similarly, government gives lot, so has given this work to different agencies and they do it for them. So I think uh, this way we can um probably so if we have data this way we can categorize them
mhm.
and end up with something, okay, that this is the problem, because before finding solution, if you don't know the problem, obviously you'll not find the solution. So knowing problem is even more important.
So, Tanya, there must have been some experiences, when you started studying mathematics that gave you a real happy feeling. And what has been like the longest duration for which you were working on a problem, for example? So, just to understand how you work.
uh, so I basically, this pure part of mathematics, it requires lot to think.
Hmm,
So uh, so there is this one subject called topology,
hmm,
and in order to complete those two chapters, you have to work like, if you work 1 hour a day,
hmm,
then you have to probably study for 6 7 months to get good knowledge of it.
okay. Hmm,
And basically that we have to do all of it in one semester. That's a different thing.
hmm,
But to understand it, and that too you'll be able to get in 7 months only when you'll do it regularly. I mean,
hmm,
1 hour day and do it regularly, then only. Otherwise, to keep everything intact, it's really difficult. So this is, these kind of stuff are challenging because you have other things also,
hmm.
and then you have to manage. So I think this kind of thing become problematic sometimes.
So, Tanya, help us to understand because obviously you've been doing a great job of it, studying mathematics very well. So, talk to us about some of the tips that you can share with other students so that they can also optimize their outcomes.
So I just want to make it clear that with my presentation, I never had this intention that you should just start liking the subject.
Hmm.
That was never the goal. The
Hmm.
goal was that at least don't be scared of it, because there's
Yes.
nothing to be scared. So what I do is uh, suppose a topic is there and I want to study that topic, then I'll probably look at that topic from different books and internet also, and so that my one topic is clear.
Hmm.
I will not do the same book. uh, I'll not go through the whole book first. Rather, I'll take this approach of choosing one topic and doing that thing from other books also. And if I find something relevant and important, then I'll write it in a note, special different notebook, so that in the end, when there are exams, I don't have to see them again and again. I just have one book, this one notebook, and I'll just flip on the pages and go through it. So I think that is how we can optimize our time. We can save time. So this is the practice I apply.
And Tanya, because you have been studying with so many different teachers, it is also important that you talk to us about what is the best kind of mathematics teacher for you, or for anybody for that matter. Hmm.
I think the teacher was funny,
Hmm.
because students are able to connect with it in a better way
Hmm.
rather than just teaching the stuff. And then I don't think so that's what students like. So the teacher who is funny and who is able to relate the things which are written in the book with real life.
Hmm.
I think such kind of teachers will be really, really helpful for students like us,
Hmm.
because I think it becomes easier, because
Hmm.
when you can connect with something, it obviously become easy for you to understand the concept.
So tell us a real life example from your own experience, where it happened to you and the teacher. You can talk about that.
Yeah, so as I earlier said that in my graduation, one teacher, I used to find him really inspirational. So he had this tactic only. He used to relate what is written in the book with outside examples
Hmm.
to connect things. So everybody in the class, we used to laugh in the, we
Hmm.
had conversations with each other, and once a question is written on the blackboard, we used to discuss with each other. There was no restriction that you can't discuss with each other or you have to discuss with teacher only.
Okay.
We used to discuss among each other.
Hmm.
And so I think that is how we can optimize uh, one session, one
Hmm.
class, because in mathematics, there is nothing as perfect example, perfect solution.
Hmm.
You can always come up with something better. There's no one solution. So it's like there are, so for one theorem there could be more than one proof.
Hmm. Hmm.
Anyone can give the proof. So I think that's the interesting part, that you can discuss with each other, find what is more effective. So that way of teaching style is also good, and I think that's how students learn better. I mean, after that class, we had to just study before exam. That was sufficient, because in the
Hmm.
class we were able to do everything. So I think that was nice.
I think it's very interesting what you're saying, Tanya, that the teacher should make the class fun. If you have
Yes.
fun in the class, then you will remember and you'll be able to retain
Hmm.
whatever you're being taught.
I had opposite experience also. wherein the teacher is just teaching from book and nobody is interested to join the class. So I think, and that also we are not able to connect with what is written. In the end, we have to do it ourselves only then. So it's no joy in studying like that. I think the actual joy is when we all study together and given the opportunity to ri- find solutions, find answers, even if they are different.
I think that is where the fun lies, that everyone is doing it together, but each one can find a different solution,
Yes,
and that scope is there.
yes.
How about sharing some tips for school going students about how they can stop being afraid of mathematics and start loving it?
So in presentation also, as I discuss some of the techniques that I use, it's really important that first of all, if we are going to school with the mindset of not learning, then we
Hmm.
will never learn. Whether it is maths or any other science subject or even if it is history,
Hmm.
we will not be able to learn if you are not going with the right approach. So approach is the first most important thing. Then second is, I think, uh, if students are not able to understand the concept, they can straight away ask then only
Hmm.
that they are not getting this point, ask the teacher to repeat it. And if the because if the this communication gap is there, you will not get the concept. Then it is important to practice it once you come home,
Hmm.
and that too regularly. If you're, it's fine if you don't exceed 10 minutes or so, but then those 10 minutes should be 10 minutes. I mean, the mind and focus should be there
Hmm.
for those 10 minutes, if not more. So I think this these techniques can be used. Yeah.
You're talking about focus. How does it develop? What are some of the ways in which probably students, because obviously there are so many distractions. How do you think they can actually develop that?
I think it's really common problem. I also had it,
Hmm.
but then I think if you want to do something,
Hmm.
then you'll always find solution. This is the first thing. Because I wanted to learn it,
Hmm.
that's how I was ready to focus. Because first of all, you should be ready to focus. If you just think that, oh, I'm distracted, I'm distracted, then you'll never be able to focus. You have to start it, and you have to think that you want to be focused. You
Hmm.
want to be focused. So that's the first step.
Hmm.
So initiating from yourself, from within, that okay, I want to be focused. Then um, I think the this is the most important part. Then later on, for many students, they listen to music and then they study. This also works because for different people, different thing works. So they can try that also. And the best thing is that it's always nice to find these kind of answers by yourself. It's difficult process, I know, but that's how this world works. I mean, one thing may be fine for some but may not be for others. So I cannot here generalize that do this thing, because it might have worked for me, but it may not work for somebody else.
Hmm.
So it's always better to find out the answers
Hmm.
within, from, I mean, from inside. I think that's the best way.
So, what are some of the absolutely specific areas in mathematics about which Tanya is very passionate?
I'm passionate about applied
Hmm.
part of mathematics. Although pure part has given me this ability to imagine things,
Hmm.
but I want to do something which is more, I mean, something which I can see and I can apply. So Regularly also I do this, like in numeric, there's a one subject called numerical integration. So uh, this topic is about that, uh, you want to find out approximation to something, like you are approximating a polynomial or something. So you can always draw it. If you know programming language, you can draw it.
Hmm.
So I think that's the plus point for me, because I know programming language and I also know the subject. I'll be able to draw it and actually see how it is working.
Hmm.
Similarly, in ordinary differential equations, the solutions are nothing but surfaces, let's say.
Hmm.
So there is a surface. So I can draw it in some programming language and I can see how that surface is looking. So
Okay.
that's how you can see maths. I mean, many people say that
Hmm.
this is the solution,
Hmm.
but I'm not able to connect. Obviously, if there is an equation written, then you will feel loss in this connection. Okay, what is this equation? But if you draw that equation and you are getting some surface, some graph, you'll be able to see it and picturize it, and then you know, okay, this is what I am doing.
Hmm. Hmm.
So I think uh, that is where I find things more interesting.
Wow. So it was absolutely great talking to you, Tanya, and I'm so happy to know that there are young students like you who are pursuing their passion and they are able to identify it at the right stage. I hope that listening to the things you said will help a few students to do the same, at least, you know.
Thank you, ma'am.
And I really found that very fascinating when you said you can see maths.
Yes.
That's a very beautiful way of looking at a subject, you know. Um, can you
Uh,
talk to us a
actually,
little about that? Hmm.
so my experience with this is that I was going through some YouTube videos of one professor teaching in the class.
Mm-hmm.
Actually, he was not teaching. He was showing some experiment with some paper strip.
Mm-hmm.
So that is where he said that this is maths, and what you study in book is this only what I'm doing. So
Hmm.
he said that if if you're able to see pictures of things, because we as humans recognize pictures in a better way than words, than big sentences written.
Hmm.
So pictures always help. And I learned from that teacher, that professor, that it's always important to make pictures. So pictures, I mean, if anything is written, so like the example that I gave, that there
Mm-hmm.
is equation written, but you have picturized it,
Hmm.
you have drawn a graph, and now you know that what is the meaning of that equation.
Hmm.
So you have a picture in your mind, okay, that this is how this looks. So that's example of picture. And there are other things also, so like into deep, but yeah, this is what we can say from our outer side. And at any point in life of this math subject, whether you are in school or any doing PhD or anything, you can always picturize, I mean, draw things,
Hmm.
because that makes things more easier to understand. That's the thing.
It's so amazing and impressive for me to see the way you're talking about the subject, Tanya. You're still so young. And Tanya, mathematics is a subject where there are obviously solutions, and sometimes you might not really get the right one. Has it ever happened to you?
Yes.
Hmm.
So even when I was in school, I attended classes, but then I was not able to grab as in what the teacher is trying to say.
Hmm.
So in one of my exams, and I don't exactly remember the class, but I couldn't pass it. I
Hmm.
mean, I think that was sixth class or seventh class examination,
Hmm.
but I couldn't pass that exam. So I had to reappear in that exam, and that time I got good grades. But there I realized that okay, practice is really important. I mean, you cannot ignore practice. No matter how good you are, or no matter even if you were a champion in your previous standard, it doesn't matter, because life is not that straight. You have to continuously work hard in order to achieve your goals. So if I don't do it today, I will not get good result tomorrow. Even if I have achieved this same thing in past, but if I don't do it today, I will not get it tomorrow. So I think that is how life works. So
Wonderful.
I think I learned from this, and then I'm doing fine now.
That's the good thing, when you make small corrections, they lead to the results that you're looking for in the long term. So,
So I could also remember one incident when uh, I made a very, so in recent exams only, I made a very trivial mistake. I exactly don't remember, but yeah, that was really trivial that nobody could ever imagine that okay, this could be a mistake. Even my teacher told me that this is not supposed to be a mistake. But uh, then I thought, okay, let's embrace it, let's accept it, and not make it again, because acceptance is really important. If we don't accept things, uh, we are not over it. I mean, uh, if you have done something wrong and you have not accepted it, probably you'll do it again. But once you accept it, okay, that I have made a mistake,
mm,
then you are more kinder to yourself, and then there are good chances that you'll not make the same mistake again.
yes, I think that's a very important lesson that you're talking about, Tanya. Make mistakes, but make new ones every time.
Yes.
Yeah, thank you so much. And I wish you all the very best and become one of the mathematicians who make a big difference to this world in your own way. Thank you for
Thank
being
you so
on Ek
much.
Samvaad. It was a great pleasure talking to you. Thank you, Tanya.
Thank you so much, ma'am, for giving me this opportunity. This means a lot.
All the very best. God bless you.